Hello, friends. We know by now that the quantum computing war or quantum computer war is heating up. There are two main contender, which is Microsoft, which has been in the news recently for Majorana 1, which is the first variant of their supercomputer, which is also the quantum computer. We will talk about that. And just few days prior, there was Google's new variant, which was known as Willow, which was the upgrade of the previous version. So we will actually compare which one is better and which is doing important things, etc., etc. But before that, let's understand what is a quantum computer. Basically, quantum computer is a type of a computer which is basically using the quantum methodologies underlying quantum behavior of the universe. We know by now that most of us know that the actual behavior is not physical. The actual behavior of a universe is explained very well by the quantum mechanics or quantum physics. And as per the quantum physics, there are no particles. It is the wave function. The entire universe is a fluctuation in our waves, and whenever there is a fluctuation which increases or amplifies, that is the manifestation of the particle at that position in this space. That is how the quantum physics explains. Now, when you look at the particle, it becomes a reality for you. When you are not looking at the particle can be doing anything that it likes. It may not be even there. That is why, in many religion and also in the quantum physics, people say that the universe that you're looking at is not real, because when you're not looking at it, it is doing something else, or it may be part of a parallel universe. So these are the things which are explained by quantum physics. So using this methodology, the quantum computing happens. That means when you are doing a computation in a normal computer, let's compare the normal computer with a quantum computer. When a normal computer is working, then it is basically bunch of switches which is either in the position of 0 or 1. It's like switching on for 1, switching off for 0, and then you have millions and millions of them in your personal computer which are in the state of 0 and 1. So it is very absolute. It is absolute that using these zeros and ones, you can actually do a whole lot of things. You can do computation, you can create pictures, you can actually create long spreadsheets, you can do analysis. So just using these zeros and ones. But then the whole beauty of a chip lies is that how you can shrink them down to a miniature. And right now, because the power consumption of the chip also matters, because you don't want to put a nuclear power plant just to power your computer, right? So therefore, how you can shrink them down to microprocessor level, and we are actually hitting the natural limit. That means now the humans have become so efficient in creating the normal computer that it cannot go beyond the miniaturization level that we have today. So how do we increase computation power? Because I think by increasing the computation power, you can solve various problems. Things like, how do you model a universe? How do you basically model different diseases that may affect us, and how we safeguard us? So these kind of computation takes many years using the fastest and the most powerful normal computers that we have. The only answer is by using a different logic which is based on the quantum physics. We can actually speed up this process, and the logic already exists for many years, and a lot of companies are investing billions of dollars creating these quantum computers. What is the underlying logic of these quantum computers? That is that it is not in zeros and ones. The bit value can be 0 or it could be 1. We do not know. It could be both. And therefore, just like the quantum physics, when you're not looking at the particle, it is doing its own thing. But when you look at electron, when you look at proton, then they manifest themselves as proton. So the whole logic in quantum physics is that it is actually in a superposition. But when you look at it, it becomes reality for you. When you look away, that means when we say observer, or we do calculations, when you look away, we are no longer observing it, then it is not a particle and it is in a superposition. Similarly, in quantum computer, the bits are known as qubits. They are always in the condition of superposition. That means whether it is 0 or 1, we do not know, the user does not know. Therefore, it is actually working parallelly, and quantum computers can process very complex problems very effectively, very quickly, because they are always in superposition, and therefore a small quantum computer can be many times powerful than a biggest supercomputer that we have today. So using this technology, Google came out with a quantum computer in 2019, and that time the Google scientists also created a buzz, or sort of a situation where the Google had to come out and solve this. The situation was that since the computing in a quantum computer is happening in the quantum realm, that means the qubits are in superposition, some of the scientists started making public statements saying that since the computations are happening in parallel universe, that is why it is so fast. It is so fast because multiple universes are working towards solving the problem that we have given, the benchmarking problem that we have given. Therefore, it can do quickly, right? How quickly? Well, a supercomputer may take 10 septillion, a septillion years, which is 10 followed by 24 zeros. Huge amount of time, which is more time that the universe has been in existence. To solve a problem, a quantum computer can solve that problem in 5 minutes. You can imagine a normal computer takes a 10 septillion years. A quantum computer can do it in 5 minutes. So it is so powerful. And therefore, these scientists, created some sort of a situation, and they said that since there are parallel universe, because quantum physics says there are parallel universe, the particles are getting manifested when you observe them, and when you're not observing them, they are either not there or they are in some other universe, parallel universe. So this computation is also happening in parallel universe. That is why it is so fast as compared to a normal PC. Well, let's not look at it anymore. Now let's look at the actual brass tacks between Google, and which is Willow, and Microsoft, which is Majorana 1. Both companies have used different technologies. Let's discuss about Google first. Google is using superconducting technology. Their chip is based on superconducting material, which has been around for last 50 years. Most of the development is happening around the fusion and the superconducting material. The superconductors exist in nature, but their superconducting abilities function only when the temperatures are brought down to extremely low temperatures. So in case of superconductor, when we say superconductor, it actually means that there are no resistance, and therefore the quantum computers, because quantum realm is so difficult to manage, it is neither 0 nor 1, so we do not know exactly what is going on. When you look at the result, then only it manifests, right? So there could be some errors. In order to avoid any errors, there has to be a logic to do error correction, and therefore this quantum computer works effectively when the temperature is brought down to very low, almost like -270 degrees. There are huge power plants to power this the quantum computer of Google, which is based on superconductors, and they are huge buildings. Actually, the superconductors computers, which are quantum computers, are very small, but to create a power situation around this requires a lot of cooling and a lot of security and a lot of cleanliness. Only in that situation these kind of computer works. But then Google has already proved that the processing power is huge. The Willow has about 105 qubits, and it is based on superconductor technology. Now let's look at the Microsoft. In case of Google, it is the old method, and Microsoft wanted to basically create something new and does not require too much power, and therefore they came up, I mean, they have spent 20 years of research and development. They have come up with a new type of material itself, which is known as Majorana, fermion. And now we are talking about, I mean, to understand this, you should know a little bit of science. You should remember a little bit of your school physics. There are two types of material which follows the Pauli's exclusion principle. What is Pauli's exclusion principle is that if there is a particle in space, there is no other particle occupy that space. That means the particle has to be so small that it cannot be divided further. So there are two types of basic particles. I will not go too much in depth, but there are bosons which are responsible for energy, because energy also, you know that Einstein gave the equation E is equal to mc square. Energy is equal to mass, right? So energy creates weight or mass, and so which are the responsibility of the bosons. There are other particles which are fermions, right? So sorry, bosons gives the energy and fermion gives the mass. So the differentiation between the fermions and bosons is that the fermions have a half rotation, and the bosons have the 2/3 rotation. So 2/3 or 1/3 or half rotation, they are called fermions. There are various examples like quarks are fermions. So let's not go too much in depth about into this aspect. Let's come back to quantum computers. So when it comes to Majorana of Microsoft, the Majorana creates its own fermion, and the beauty of this, it's like Microsoft is claiming that they have created a totally different type of material. Majorana fermion actually is like a particle as well as its own antiparticle. So they're using this kind of material, which is how they are creating it. It's known to them. They may not reveal this technology that they have developed, but the whole point is that in this case, they can use the material intrinsic ability to flip between matter and antimatter, and therefore they don't have to use the superconducting material. They have created a different lattice for holding their qubits, and they don't need a lot of power to make sure to basically run their quantum computer. And they have created the material which is a combination of iridium and aluminum. So instead of using any other superconductor, they are using basic material. How they are doing it, it's known to them. It is not revealed. This they have taken more than 20 years to come up with this, and therefore from their point of view, this is groundbreaking. They have taken a totally different route to create their quantum computer, and their first variant, which is Majorana 1, has only 50 qubits, but since it's a quantum computer, it is going to be very, very powerful as compared to normal computer. Now when we talk about this quantum computer, where it will be used, both, which is Willow as well, Willow from Google and Majorana from Microsoft, they will actually use this for material science to start with, because quantum computer may not be available in your PC or in your mobile phone. It will not be available in your pocket, because quantum computer with this kind of processing will be used for basically solving the world's problem, right? And one of the biggest world problem is how do you basically create much more smarter material, or how do you basically get rid of the microplastic that is now affecting the entire nature. What is the way we can actually get rid of the plastic? How we can utilize our latest quantum computer to come up with a solution which will help us degenerate the microplastic. And the next problem will be, how do you basically create space suits, spaceships which can withstand huge amount of radiation and also pressures of the outer space. So I think the quantum computer, as both Microsoft and Google are talking about, is that deployment of these quantum computers will take place in resolving the material, next generation material, which will be made from maybe carbon, maybe at the atomic level, how many molecules or different atoms or different material or different metals will be attached, and how they will be laid will be calculated by the quantum computers. Because right now we know how to mix these material and come up with a different alloy, but beyond that we do not know. So the quantum computer will be able to help us with this riddle. That is where both companies are putting their money. And now the other thing is that Microsoft has even said that almost 40 to 50% of the code of this logic of quantum computer has been written by Copilot. So it could become a sort of a partnership between quantum computers and AI, where AI will write the code for enhancing the quantum computer, and the quantum computer will then create much smarter AI, which will have the ability to understand human emotions, human logic. They will be actually the future of the AI using quantum computer, maybe much more very realistic, very close to human, and then you can have a proper AI using quantum computer going and becoming an autonomous system, exploring the solar system, exploring the galaxy. So I think to start with, both companies are saying that we will actually use quantum computers to create next generation, next level material. Second choice will be to look at finding solutions for very deadly diseases like cancers, how we can actually help humans to come up to conquer cancers and other diseases. So there could be modeling, medical modeling based solutions for fighting these kind of diseases. So I think both companies are going to use this, and therefore, which is better? Well, on the face of it, the Google Willow looks more stronger because they have 105 qubits in their PC. On the other hand, Microsoft says that their quantum computer does not require the huge amount of power to run the quantum computer, but they have only 50 qubits in their Majorana 1. But this is the first variant. Maybe they will also start competing, and Google has already given that their Willow can actually perform a problem or solve a problem within 5 minutes that a normal supercomputer, the world's biggest computer, will take 10 septillion years. So Microsoft has yet to come out with these kind of figures. Microsoft has to still do a lot of tests, but both technologies looks very promising. Maybe at some point in time in future, there could be a collaboration between Google and Microsoft to come up with a perfect variant of quantum computers. So this is something which is I thought I will discuss with you live. If you have any questions, feel free to send across your questions or your comments. Friends, thanks for watching, and I will catch you again in the next one.